Okay, and these next problems that we have here, that says Tom keeps all of his favorite marbles in a special leather bag. Right now he has 5 red marbles, 4 blue marbles, and 3 yellow marbles. For this one, we're just going to call that yellow. I don't have a yellow feature on my board. I just only have orange, so we'll just call those yellow. What it's saying here is if he randomly chooses one marble to give to a friend, what is the probability that it is blue? What you do have here is you do have 4 over 12. The only thing I would suggest, though, is what you're going to want to do is you will want to simplify this fraction, because even though they don't specify whether they want percent or fraction, you're going to want to simplify this regardless, because both of these numbers can be divided by 4 here, which means 4 divided by 4 on the top gives me 1. 12 divided by 4 on the bottom gives me 3, which is 1 over, 1 in 3 chance that you'll select blue. Okay. Once again, we could, divide this out and times it by 100, which we are going to get that 33.3 repeating decimal. I would have to suggest probably the fraction's the best way to write this one, is a 1 in 3 chance. Now, the next one in this one says he doesn't want to give away blue marbles. He wants to get it to where the probability is a 1 in 10 shot instead of 4 out of 12. Okay. Now, the question for they one is how many red or yellow marbles does he have to add in order for the probability to blue to be a 1 out of 10? Well, how we want to do this is I have to figure out what this would look like if this was 4, okay? So what I want to figure out here is I'm going to kind of work backwards than I typically have been doing stuff. I want to figure out how can I go from 1 to 12, and what I need to do there is I need to multiply by 4, okay? Now what I do at the top of this fraction, I'm also going to do to the bottom. I want to do to the bottom of this fraction. I'm going to have to multiply it also by 4. No, it's not. So, once again, that's my youngest son. You'll just have to deal with that. I'm working here real quick, buddy. So, on the top there, if I get 1 times 4, that is going to give me, still going to give me the 4, okay? But if I do 10 times 4 on the bottom, okay, that's going to give me 40. Now, the reason why I'm doing this is the same probability that they want. They want a 1 out of 10 chance. Well, that would look like 4 out of 40, okay? So the question is, how do I go from 4 over 12 to 4 over 40? Well, how many total marbles more is it from 12 to 40? Well, the only way to go from 12 to get to 40 would be to add 28 marbles, okay? Now, once again, the reason why we're doing this is we want to get the probability down to 1 over 10. Well, the only way to do that is to, instead of having 12 marbles in the bag, and with 4 of them being blue, we're going to need to add 28 other than blue marbles to it to get to that probability. So in the question here, they ask how many marbles that are not blue. We need 28 not blue marbles. Okay. Once again, we figured that out because we had to change this to make it look like a 4 on the top here. That way we knew how many marbles it would take for the bottom to make it be the 40. It's okay. Now the next one's here. We have, let me find the number here, which is this one. Mario was visiting the carnival when he noticed a few number relationships he made. He says, if 3/10 of the visitors were adults and there were 100 visitors, how many visitors were adults? Okay, so here's our 3/10, and he knows that there's 100 total visitors at this place, and we want to know how many adults there must have been. Well, this is like what we just got done dealing with. Is I got to figure out how can I multiply something by 10 to get to a 100? Well, that would be 10 times 10. And what I do to the bottom, I have to do the top. So we're going to multiply it by 10. So on the top, we're going to get 3 times 10 to give us 30. It would take 30. That means of the 100 adults or 100 visitors that were there, there would be 30 adults. And I notice here on your notes, they have the times 1 rule. Well, Yeah, that's just like a big one, sure looking like thing there. I don't know, I can't draw a one. So yeah, this right here is basically your times one rule that you're dealing with. Okay. Now the next one, done the same way, except they kind of try to throw a curveball at you a little bit. It says 5/8, which I have right here, of the prizes are dolls. Okay, so of the 8 prizes, 5 of them are dolls. Now, the question they're asking is, if there are 64 total prizes, how many are not dolls? Okay, now what's the easiest thing to do here is to figure out how many it would be dolls like we did up here, and then we are just going to have to see how many are left over. So what I mean by that is, if I did the same thing I did on the last one, how do I go from 8 to 64? I times it by 8. What I do to the bottom, I have to do to the top. So on the top, I'm going to have 5 times 8, which is 40. Now this tells us how many of the prizes are dolls. If we don't want the dolls, we're going to have to do 64 minus 40, okay? Because we know 40 of them are dolls, but there's a total of 64 prizes. So to figure out how many are not dolls, 64 minus 40 gives me 24 are not dolls. Yoink, yoink, yoink. I'm going to read the instructions here real quick. Yep, that's all we will need to put for those ones. That's good. I noticed on this one, I believe you had it answered, but want to kind of make sure, maybe I missed something here. So I want to put these from least to greatest. Now, typically what that means is I would want to get them all to be something similar. So you'll notice that you have integers, which are numbers with no decimals. You have fractions, you have decimals, you have all sorts of things here. What would be easiest is to change all of these into a common one. Easiest one to do that with is to make them all decimals. So for instance, if we have a fraction, we're going to do the top divided by the bottom. So the first one is 1 divided by 2, otherwise known as 0.5. The next one is 1.1, so it's already ready to go. Okay? Then I got 5 divided by 3. Now this one's a little bit more challenging because it gives me that repeating decimal we talked about earlier. But I'm going to go ahead and put this one as 1.66667, which actually I like just to prefer to put my little bar over that last 6 to let me know that that 6 keeps on going. 2 I'm going to leave alone, 0 I'm going to leave alone, 0.4 I'm going to leave alone, -2 I'm going to leave alone. Because technically I could make all of those decimals by doing like 2.0, 0.0. That one's already a decimal, -2.0. So I don't really need to worry too much about those ones. Now the last one here, 5/8, that is going to be 0.625. And that's it. It's not a repeating decimal. It's actually that terminating decimal that we talked about before. Now, if I remember from your paper, you do start out with the correct first one. Okay, the correct first one is the -2 because it is the only negative that they give us. Okay, now as I go through these, I'm going to do this in a different color just for my sake. -2, and as I go through these, I'm going to cross out the ones that we are using here. Okay. Now, the next smallest decimal that we have here is 0.4. Actually, no, I did forget one right there because I do have a 0 right there. 0, okay? Now, the next one that I have, it's the smallest out of these decimals that we have, is 0.4. 0.4, and I'll cross that one out as well, okay? All right, next one that we have, I have right here at the beginning, the 0.5, because I have 0.5 and 0.625 as my only ones left that start with zeros. Now, obviously 0.5 is less than 0.625, and so when I go to write this down here, I'm actually going to write it back as the fraction that it was, okay? So that 1/2 will be right there, and instead of writing 0.625 for the next one, I'm going to go ahead and put my 5/8 for the next one. Then let's see what we got left. I have a 2, I have the 1.6666666, and the 1.1. Now the next biggest decimal we have is the 1.1, so I'm going to go ahead and put that here. Then I got the 1.6 repeating, which I want to go ahead and put it back as its original fraction. And then I have the 2 right here for my last one. Okay, so on those ones, it's always easiest to get them all to be the same thing. And like I said, the easiest one to change them all into is the decimals. Okay, all right. Go eat dinner. Go eat dinner. Okay. Next one says, what is the probability of getting either blue or green on a spinner that is 3/10 green and 1/5 blue? Well, if I want to know the probability of rolling either this or if I want to know the probability of rolling green or blue, I just have to add them together. Now, unfortunately here, 3/10 plus 1/5 don't have common denominator. So we are going to have to get them to be the same denominator, which means this bottom number on the 1/5, we're at the times by 2. And like we did earlier, what we do at the bottom, we have to do the top. So I'm going to times the top also by 2. Now, I will still have that 3/10 at the beginning, but I'm going to have 1 times 2, which is 2, 5 times 2, which is 10. And then when we add fractions together, bottom stays the same. Let's add the tops. 3 plus 2 gives me 5. And once again, we do want to simplify, so we are going to divide both the top and bottom here by 5 to give us 1/2. Now, once again, what is the probability of either of that? Once again, if they want fraction, we're done. Otherwise, we'd have to divide those out and times it by 100 to give us the 50%. Like I said, I don't know which one they want you to do, so that's why I kind of show both of them right there. Okay. In this diagram here, they want us to, if you were to spin the spinner at the right, what would be the probability of landing on the green or purple? So let's see here. We got green or purple. Okay. Now, the green section is taking up half of the circle. Okay. So the green circle is taking half the circle, so we can think of that as 50%, or we can think of that as the fraction 1/2. Okay. Now the purple section, okay, is taking up a fourth of the circle because it's half of a half, and half of a half is 25%. Now, like I said earlier, I don't know if they'd rather you do these in percentages or fractions. So once again, we'll show both. The easy one on this one is probably to actually go ahead and do percentages, because if you know it's 50% for the green and it is 25% for the purple, well, in order to figure out what it would be, green or purple, add those together to give us the 75%. So that if it was a percentage, that's how we'd want to go about handling it. Now, if I did the fractions, though, I'd have 1/2 plus the 1/4. Just like we did in the last one, we are going to have to get common denominator. So on this first one, we are going to have to multiply the bottom by 2 to give us the same. And when we do to 1, we have to do to the other. So we would end up here with 1 times 2, which is 2. 2 times 2, which is 4. Add that to the 1/4. 2 plus 1 for the top gives me a 3. Common denominators means they stay the same. So as a fraction, this would look like 3/4. And you might be able to make that justification by doing this one up here, since it was 75%, because that's what this is as a decimal. Okay. I think the last thing I have for you is I saw you completed this one. Now, this one was a little bit off, so I want to kind of explain here what we had going. Okay, I'm just numbering my axes. Numbering my axes here real quick. Okay. Now, you put the numbers 1, 2, 1, 6, and 7, 4. Now, the 1, 2, I'm figuring you got from this. The 1, 6 you got from this, and then the 7, 4 you got from this one up here. Okay. Here's the deal with coordinate points. Okay. It's the x coordinate first, then the y. The x coordinate is the one that runs horizontal, side to side. The y coordinate is the one that runs vertical, up and down. So I want to know if this point down here, I have to go over 2, up 1. So my first coordinate point would actually be 2, 1. And you might be able to guess where I'm going with this. Instead of 1, 6 on the other one here, this would be 6 over, then 1 up. So that means we would want to put 6, 1 for that one. And then finally, instead of doing up 7 over 4, it's travel 7, so travel 4 to the right, and then go up 7, because it's always the x coordinate first, then the y. And then the last thing I would say with this one also is you don't want to write them. This is why I tried to write it just like you did. You don't want to write them like this. You want to make sure that you're including, anytime you're talking about coordinate points, you got to include those parentheses. So I would say this is a good way of showing your final answer. Another way you could show it is just by putting a comma that separates all 3 of these coordinate points together, okay? Like I said, this one you had the right numbers. Unfortunately, you just put the wrong one first when it came to the coordinate point. And that should be it for this one. So hopefully this helps.